Part A here, we've got an equation, okay, trigonometrical equation, which we have to solve. Now it involves sine squared and cos squared, isn't it? So we're going to use the rule sine squared plus cos squared is equal to 1, right? And we need to get it common, don't we? At the moment it's got sines and causes. We need to have it so it's just got one trig type function. So I would get rid of the cos squared, yeah? Because we can't get rid of sine. Sine theta is there to stay, so we get everything in terms of sine. So we can say, look, since sine squared theta plus cos squared theta equals 1, cos squared theta then, well, if you take the sine squared over, so cos squared theta will equal to 1 minus sine squared. So sub that in, right? So we've got 6 sine squared theta plus 1 equals to 2. Bracket, now cos squared, remember, is 1 minus sine squared. Okay, minus then the sine theta. And then we've got 6 sine squared theta plus 1 equals to then, well, let's multiply that out, 2 minus 2 sine squared theta minus 2 sine theta. So take that over there, everything over there to the left hand side, so I have 8 sine squared theta, okay, plus 2 sine theta. And then we've got 1, and if I take that 2 over, it becomes minus 2, so I'll end up having minus 1 then, equals 0. Okay, so we're going to try and factorize this, put it into two brackets, so 8 sine theta in both brackets, and multiply, add thing. And remember, you multiply that first number by the end one, that's minus 8, and it's going to add up then to give 2. And because we multiplied by 8 there, we're going to now divide by 8 here. So we need two numbers to multiply to give 8. Well, 4 and 2 works, yeah. I can get them to add up to give 2 as well, easily. Just make it plus 4 and minus 2. And they'll multiply to give minus 8. So that's good. So plus 4 and minus 2. Now, you can see in the first bracket there's a common factor of 4, so we can take 4 out. And we can see in the second bracket there's a common factor of 2, so we can take 2 out. So they cancel, so you get that then. So you could say, look, 2 sine theta plus 1 equals 0, or 4 sine theta minus 1 equals 0. So sine theta will equal to minus a half, or sine theta will equal to 1/4. Okay, so let's just do sine to the minus 1 of minus a half. Okay, so we get minus 30 degrees, and do the same here then, sine to the minus 1 over 1/4. We get 14.5 degrees. So we need now to draw our sine graph. Okay. So with our sine graph, we're then going to have to go every 3 centimeters to be 90. Now I'm going to have to go back to minus 90, of course. Okay, so I've got 90 here, 180, 270, 360, and minus 90 there. 1 here, minus 1 there. So we know sine 0 is 0. We know sine 90 is 1, sine 180 is 0, sine 270 is minus 1, sine 360 is 0, and sine minus 90 is minus 1. Okay. So then a nice scale enables us to draw a decent sort of looking sine graph. So the first solution, sine to the minus 1 and minus a half. Now minus a half is here, isn't it? Okay. Which, so we draw a straight line across there. So the result we had is minus 30. Of course, that's outside our range, but we can use it to sort of use symmetry there to work out the two results we want. So it'll be 180 plus 30. So that would be there. Or 360 minus 30. So we get 210, 330. The other result then, 14.5 is when it's equal to 1/4. So quarter, we'll draw a line across. So that's where quarter is here, 14.5. So that result will apply, won't it? And of course the other result is there. Using symmetry, you can see it's going back from 180, so it'll be 180 minus 14.5. So theta then be 14.5 or 165.5. Okay, so overall then we can put these in order. We can say theta is 14.5, 165.5, 210, 330.